Good morning, everybody. This is the latest instalment of the regular Wednesday webinar series from the FIWARE Foundation. My name is Jason Fox, and the subject of this episode is an introduction to what is an IoT agent. The concept here is how to get context data from real-life devices through to the context broker. So the learning goals for this session are as follows. You will come to understand what is a transport and what is a message protocol and why this isn't pure FIWARE and why we need to deal with them. What are the terms northbound, southbound, north and south port mean as regards data communications through FIWARE? How commands and measurements from devices, either actuating the device or retrieving the information, is going to be processed. And then what actually is an IoT agent and what does it actually do? How can I configure up an IoT agent? How can I get it so it'll work over HTTP? How can I get it to work so it'll work over MQTT? There are various different ways you can actually get data from real-life devices into FIWARE, and obviously it will depend on what the device is as to what you actually need to do. So if you wish, you can follow on by downloading the tutorial series, which has got all the data which I will be showing later on in this session. The prerequisites are, as usual, Docker, Docker Compose, Git, Postman, and Cygwin if you are running on a Windows machine. All the information is available, so you can download it at your leisure. You can see the how to clone the repo on the screen at the moment. Just as a reminder, the FIWARE catalog consists of 5 main chapters. Core context is the one in the middle. That is what FIWARE is all about, mainly interaction through the Orion Context Broker. But today we are looking at the box at the bottom, which is a connection to the Internet of Things via elements such as IoT Agents, IDAS, or you could use an alternative like OpenMTC. You could also abstract this idea out to connections to other elements in general, such as connections to robots and what have you. However, that will be a subject of another webinar later on in the system. So what we have here is that we are having data moving from an unknown or differently well-defined protocol up into our FIWARE NGSI layer. So it's between the dark blue box and the cyan box is where we are getting communications. In order to do this, we're going to have to start off by creating some sort of dummy sensors. This is the simple example we're going to give. We're going to use a message format called Ultralight, which is a message protocol, is the format in which the data is exchanged. If you think about it, you could have a very verbose format like, say, XML, where you've got lots of angle brackets and lots of data in there. You could have a very tight format like just binary bits, because your device has got is very constrained into what it can do. But the point is that any transport of data is going to be in a format which is going to be understandable. Now, the Ultralight format is a good example for teaching this sort of thing because it's relatively constrained, but it's still basic ASCII characters, so you can actually see what's going on. Now, in order to get the message passed from the device to this IoT agent layer, you need to have some sort of transport mechanism. The transport mechanism is the way in which the data is passed from A to B. Now, you are all familiar with the HTTP protocol. You're using the internet on a daily basis. It is a request response protocol where you send your data, you get it back, a response from the other end saying, yes, I'm connected to you, and we can talk thereafter. There are alternatives. We'll deal with another alternative. The point here is that, again, depending on your device, it may or may not be capable of taking various different transports. If you are in a particularly constrained scenario where you've got really low power constraints, you won't want to have the overhead of using HTTP because you won't want your device to be always on. So you must consider, when you are connecting your devices, what is the transport and what is the message protocol, because there are various different IoT agents to cover each of these scenarios. Now, for the HTTP transport, the IoT agent will be listening on a endpoint for device traffic. This is data coming from the bottom of the stack, and therefore this is known as the south port of the IoT agent. This is, as you can see, a situation where you may have information which is going down into the devices, such as I want to ring a bell, or you may have other devices which just give you measurements, such as I'm a motion sensor, someone has passed by. You could have a more complicated devices which can do both, like say I can switch on a lamp, but I can also retrieve the luminosity of that lamp. So you can see that information will potentially either be passed out into the devices, or it is equally possible that it may be coming in from the devices. The south port is the top of the arrows on this diagram, which is saying, hey, on this particular port, I am listening. Now, because we're using HTTP as our transport, again, the devices must be listening to something, and the arrow on the lower half of the screen is the port in which the devices are listening on. So let's start off with a practical example. Let's start up my dummy devices. This is where we will get our stuff on screen in a second. Okay. So at the moment, I'm loading up a series of devices. I've got various bits on screen here. Okay, fine, that's it. Right. So for Ultralight, Ultralight is a message format where you have a string saying, I am would like to be known as device X. I want to do something, and I will then expect something else to come back. So if I want to say ring the bell, I say I want to ring the bell. Go off and tell me, can I ring the bell? And it will say, and I just get this running. Now, initially, audio is off on this thing, so I've got to press something to get audio on. So it says, okay, recognize me as this. I am sending information to my devices on this particular endpoint, and I'm putting this as my payload. When I send the payload, as you can hear, the bell rings, and it returns the response saying, okay, I have received my response and I've got something coming through, which makes sense. If you think about it, there should be something going out there and it will return immediately on the same thing. I can also do something a little bit more complex, where if I have, say, my lamp, I'm again going through saying I want to send information from my lamp and switch it on. You can see that's part of my my request. I can send it, and you can see my lamp has switched on. But look, it is now also sending information back out saying the luminosity is whatever. So you can see that it is sending to a different port. It's sending to 7896, but it's sending the information. The status is on, the luminosity is whatever. So you can see when it's sending data, it's passing information as separated by the pipe character with ASCII in there. Now, at the moment, nothing's listening on there, but we can see the information is passing through from A to B. Similarly, if I wanted to send a switch off command, again, it's the same thing, but I would just have off in my body rather than on. You can see. And if you look over on the screen, you can see my lamp's coming off. Now, at the moment, all the stuff I'm doing is being passed in a very proprietary manner. It will depend on whichever device you've got, whichever standard you're using for passing your data, whether you are using this transport or that transport, so this message format, that message format. You can see this is the sort of problem that an IoT agent will try and solve. Similarly, we could do the same things by locking or unlocking doors or what have you. So we now can move on to actually getting the IoT agent to do something. An IoT agent is there to translate the specific protocol, in this case HTTP and Ultralight, into NGSI commands and talk to the context broker. So everything in the cyan, the pale blue at the bottom, is in some sort of format which is a class of devices, whereas everything which goes into the context broker from whatever system, whether it is the supermarket tutorial we showed in a previous episode, or it's coming from the IoT agent, or it's coming from somewhere else, all of that must be done in NGSI. Now, we have at the top of the IoT agent, we have a north port, which is used for communication with the context broker and also used during configuration of the IoT agent. The south port, as I mentioned previously, is the one which is used for taking traffic to and from the devices. So let's start up a slightly more complex system where we've actually got an IoT agent in our mix as well. This is an additional element which is listening on port 4041. Now, again, this is Dockerized. So what we would do is we have here a configuration file which is within the system itself. But we also have the ability to override various attributes. So as you can see, if I scroll down straight to the bottom again, you can see the default transport for this particular IoT agent is MQTT, and it is representing itself with the key TEF normally. Now we can override these things. We can also set up things like what the basic service, in other words, which tenant we're using for this, so or what sub-services we're after, and also it can say this is where the information for the IoT agent is listening for the context. In other words, this is the north port, or whether we need a in-memory or a database for holding the state for the configuration of the system, which we will see in a second, and so on and so forth. If we look at the actual where are we? If we look at the documentation for this system, you can see that it is possible through Docker to override a wide variety of the configuration files I've shown on the right. You can set things up like authentication if you wish to secure your system, you can set up what is the north port and what is the host of the north port and so on and so forth, whether you're using NGSI v1 or v2, and so on and so forth. All these terms, which is the general stuff like which database you're using, is based on the IoT agent node library. Whereas for Ultralight itself, because it is a specific IoT agent, there are additional elements such as where is my MQTT host, or which HTTP port I'm listening on, which I can add in as Docker environment variables. So you can see you can configure these things using different mechanisms. You can also, if you're just using the straight config, you can actually just run these agents directly without being in a containerized environment. Move back to my devices, which was, where are we, this one. Okay, so we now have an IoT agent running, and it says here it's running on 4041. We can check that the thing is running by doing an about on the about endpoint, and if I send information there, it retrieves what version of this particular library and which port it's running on. Obviously, if you're sending data to a different port, it won't be listening there, so you need to know what you're doing. And it says that the library version, in other words, the common base information it's got is, in this particular case, 2.8. You can see when we are setting up a series of devices, we need to set up a service group. Within the service group, I'm setting in the FIWARE service header, in other words, the tenant, saying that I want to consider this group of devices to be in the OpenIoT group. And I'm using the default service path. You can use the service path to subdivide your information into various different areas. So the example is, let's say you have all the information for parks and gardens in a city. You could then divide that into a specific park or a specific flower bed within that park to try and get the information for that particular area. And of course, you can then reduce the information you would receive as necessary. Within the service which I'm setting up, I am saying I have the following context broker, which is Orion, which is running on 1026, and I'm using this following random key to recognize that when information is coming through from my device, it is saying, yes, I really am a device you really want to listen to, for the simple reason that I know what this key is. You can secure things in a more secure fashion, but this is just a simple sanity check. The entity type here is if information is being sent from devices which has not been recognized yet, it will default to the entity type of thing in this particular case. If I go back to that configuration file, you can see the configuration file also can set up a default type so that we won't need to set things up if we have something else. This is just an override in this particular case, but you can just set up an entire class of devices within the system. So when I set up the service, it returns the fact that the status has been created and no particular information there. This is just giving you the fact you have a group. Now, next thing we would need to do is to actually provision the device within that group. So we're saying, okay, when we have information on that IoT/D endpoint, and it also identifies itself as motion 001, which is something which is coming from the actual device, which could be not unique within our system. I want to call this with a FIWARE entity, and my particular FIWARE entity has got a NGSILD format saying this is URN. so it will be unique, and I want to have the following type of entity when I'm coming through. Now, within the Ultralight configuration, you can map attributes to entity attributes. In this particular case, the Ultralight syntax is saying we have something called C slash something slash something slash something slash something, and I want to consider this to be the count. It's either a 1 or a 0. Similarly, you can extend the devices which are retrieved within this system by adding in additional static attributes. In this particular case, we are saying motion sensor 1 is in store 1, which we had from the supermarket example earlier. This means you can then have linked data between one class of entities and another class of entities, so you can traverse the graph. Once again, it returns status of created and not much information coming back. As you would probably expect, there is a Swagger API which deals with all these pieces of information. You can set up your services using your standard HTTP verbs, and similarly, you can get information about which devices are coming through. If we send a measurement, again, this is just directly pushing something into the south port. You can see I am saying I am motion sensor 1, and I am putting in this string directly, and I've got that special key in there, and I've got this IoT/D, which is the service part I can put in. I can send that, and the response is saying, "Yep, something. I've received something." But what has happened now is that if I now look into Orion and look for the motion sensor I should have set up, I have automatically got the full information about that motion sensor into my system. So you can see I have now got a proper NGSI entity out of data I have put into the system. So this is now calling itself motion 001, and it's got the appropriate type. Because I have set up the configuration to include timestamps, it will also say this is when I was last updated, and within the metadata of the count, it's saying I received a count measurement at this particular point. Obviously, if you have a system which is only waking up every 20 minutes, you will end up with potentially information coming from your devices which is not real time, it's right time. It's only when it's able to receive the information. So these values could be not instantaneous, they are more likely to be behind the curve. In order to send commands down to the devices, you would need to set up a command within your provisioning of the IoT agent. Once again, you can see within the IoT agent, we are looking at this north port, which is used for the admin of this element. This particular one is saying, okay, I am a bell. I am known as URN LGSILD within Bell 1, within the context broker. So you've got some sort of mapping. But when I am sending something, because I am using HTTP, I am actually going to pass my information further onto this URL here, this is the where the device is listening. Furthermore, I can send the following commands as necessary. Once again, it's in store 1. So we can send this information down to the system, as you'd expect, because we're just using a REST API. The response is held within the HTTP return. Now we can also invoke that command. Now, before I start putting stuff into the context broker, I'll just put information directly into the IoT agent itself. And if I send this, saying I want to update the following context element within that particular device which has been set up by the IoT agent, you can see that the bell went on. I'll just take motion, so make sure I've got some sort of audio on there. And you can see the bell goes in. Now, because I'm using HTTP, there is an immediate response here. We're saying, okay, you have sent me a command, and I have returned the information about that command. This, again, is the translation between the protocol, the message format of the bell itself, which is in Ultralight, and it has returned it back up to the system within a NGSI format. So if we now look within the context broker itself, you can see that we now have got, if we just look for bell 1, we're just using the key values one rather than to get the full metadata. You can now see that the status of the ring was okay. Potentially, we could have a command which is in process, we can, or it's not been completed yet, and the status would be not okay. If I remove the key values from here and send the thing again, it will give me further information such as when the thing was processed and what results we received back. We could very easily add in further information to connect up a door or a lamp to get more information coming through. As you would expect for the API here, we have the standard CRUD commands for manipulating this system. We can create new service groups, new groups which have got common information. We can list all the information we have retrieved from the system. So this will say, I have currently got the following service groups. And similarly for the devices, we can list or amend or delete information from the devices we've got. So within the devices endpoint, you can see we've got a large number of devices which have been going in because I've started some automatic responses from the other devices. You can see we've got motion sensor 3 in here, for example, which, because I haven't actually configured it myself, it has taken the type of thing, because this is what the default is because it sent something up with that secret key saying, hey, motion sensor 3 actually exists, and therefore we can do something with it. When you are sending messages, measurements up from the device to the context broker, the device takes a measurement reading and passes it into the IoT agent. The IoT agent receives that, translates it as necessary, and then passes up into the context broker. This is what's known as northbound traffic. If you remember the information, the diagram where the devices at the bottom, context broker at the top. This is going from bottom to top. This is northbound traffic. Obviously, the information, once received from the IoT agent, it knows where things are going. Therefore, it's a direct line. It's quite simple to get information from devices up to the context broker. It is slightly more complex when you are taking information from say a user interaction, pressing something, into the devices themselves, because what you will need to do is you will need to have a attribute changed on the entity within the context broker. Then, because this device has been set up using the IoT agent, the context broker knows that somewhere else is responsible for that device. So it will then delegate the information down into the context broker, into the IoT agent, get that right. And at this point, the request will reach a pending state. Now, this is not necessarily going to be in a pending state for very long, particularly if you have an HTTP request, but it informs the context broker, fine, you've told me I need to do something, I'm going to go and do it. at that point, because it knows how to translate between NGSI and whatever the protocol at the bottom is, it is able to, say, send stuff to the device. The device will eventually give you information saying, yes, I've processed it, in which case we will then be able to update the context to say, this has happened correctly. Now, it is not necessarily the case you'll be using HTTP. You can, more likely with IoT devices, you'll be using some other alternative transport. For Ultralight, the commonest version, indeed the version which is set up by the default configuration, is MQTT. So let's set up the same system, but instead of using HTTP requests, let's use a different transport. Some IoT agents are able to deal with multiple transports, some aren't. Some are more specific to whichever protocol you're actually using. So in this particular case, the idea of the south port is a little bit more vague in that it's where the IoT agent is listening. It's not literally listening on a port. It's doing it, listening to, in this particular case, MQTT topics, and therefore it is completely irrelevant to the context broker as to which system you're using. It is just the context broker is purely receiving NGSI information, whereas down at the bottom you could be doing whichever transport and whichever format you're talking about. Let's start up an MQTT system. You can see I've now got an additional element, which is the MQTT broker, Mosquito, and this is a publish subscribe protocol. So you send topics to the MQTT broker to say, anyone want to learn about this? And assuming that someone picks it up, they will eventually say, yeah, you've got any messages for me? So it's no longer direct communication. So as you would probably expect, it's going to be of it will have a lower power requirement. You can see if we tail our logs, we've got a few clients which have connected to our system. So let's subscribe to a topic. You can see nothing happening there because it's now just listening. If I were to actually send information into the system, you would see this is motion sensor 3. We're going to send some information on that particular endpoint. You can see this is my magic key again. This is saying who I am. This is my attributes. And again, you've got the actual topic message is in Ultralight format. We can send something, and it has been received within the other endpoint. So let's see how we would actually connect something using MQTT. It's very similar to using the other version of the IoT agent. So we just check mosquito health. Once again, we can set up a service group. We're saying we are in this particular service. In other words, this is our tenant, and we are not using service path, so we're using the default service path. And once again, we're saying this is our magic key, and we are connecting to Orion and its key. You'll notice that the resource is blank. This is not required for this particular version of the IoT agent because it's irrelevant for the MQTT system. So we send that information. And once again, you can see there's information coming through, nothing in the body, but it has been created. And we can provision our sensors once again. Once again, we have the same thing here. So we're on that particular device, and we're saying if we have motion 1, then if there's a C, it goes into count, and so on and so forth. You can see that there's information in there. Because we haven't sent it any topics yet, there's no information from the account itself. It is currently blank. Similarly, we can set up our actuator like our bell. Once again, it's saying this is the tenant, this is the service path, and we're saying we have the following commands which are available. If I go back to my devices here, you can see that when I go into the IoT agent directly and say, I'd like to ring a bell, it is actually sending a topic to the MQTT broker. And you can see it in both places here. And it is then retrieving a second response from the device itself. So you can see that something is, messages are passing through the system. This is obviously a little slower than it would be through HTTP, but is worthwhile for this particular setup. So once again, having done something like that, we can retrieve the information directly from the entity within Orion itself, and it's saying, hey, this is a type bell. Last thing that happened was then, and the ring was okay. The reason you didn't hear it is because I've only just put the audio on. Now, if I update the context broker, this is not necessarily the required step, but is quite useful. If I tell the context broker that as far as this entity is concerned, we want to pass information with, in this particular case, legacy forwarding equals true, which means we're using the NGSI v1 format for our registration. It will say, okay, I now know that when this information is requested or updated, it's somebody else's problem. We can then use things like the patch verb to actually update an attribute of our bell entity. If you look at the body is saying we're going to update the ring attribute of the bell. And as you can see, I am now passing information from the context broker in NGSI format, and it is passing all the way down into the device. You can see, as far as users of the context broker are concerned, they have no idea what the protocol for the actual device is, whether it's Ultralight, whether it's JSON, whether it's LoRaWAN, whatever, it doesn't really matter. It's all the case of just send your HTTP to your context broker. The context will change. The information is saying I will pass the information out to the IoT agent. IoT agent will deal with the nitty-gritty of actually changing into whichever IoT platform is underlying this. This is the FIWARE way of getting around the fact that there are multiple IoT platforms out there. Each one has got a relevant purpose, but it only covers a group of devices. And we are a layer above that, which means that we can just do this for all sorts of devices. So, in summary, a message transport is the mechanism through which data is exchanged. Examples such as MQTT, HTTP, LoRaWAN, Sigfox, blah, blah, blah. And you have within that a data format, message protocol, which defines the data itself. This could be anything from binary data up to, say, XML. and everything in between. In order to amend the state of a device in the real world, you need to send a command. And the command is what we did just right at the end, goes sent it to the context broker. Context broker then sends it to the north port of the IoT agent, which then works out what needs to be done to send down to the devices. In other words, past southbound. Measurements come the other direction, which is the readings from the device. And again, the final situation is that you get the information within the context broker. The north port of the IoT agent has multi-use. It is used for sending the configuration if it's not already in the config file or you've not set up Docker environment variables. It is also used for sending devices to the command itself, to the IoT agent, and then the devices themselves. So, in summary, the IoT agents overcome a common problem in the IoT domain in that we have one overriding standard, NGSI, north of everything, and we want to be able to translate to different protocols, different standards, because there are different standards out there. So we are translating into NGSI v2. Now, if you have a device which you want to connect to FIWARE, make it FIWARE ready, if there is an existing IoT agent, then effectively it just needs to be certified it's FIWARE ready, because you can get the communications. Can you get from A to B? If you are in a situation where you have an unsupported protocol, there is a mechanism to create your own IoT agent, because there's this IoT agent library which basically gives you blank endpoints. So you can say, okay, I now need to set up my MQTT to listen here and then pass information here or do this. Now, furthermore, you may be in a situation where you have a device which can be FIWARE ready without an IoT agent, in that the device itself could talk directly NGSI v2, or it could be talking through FireOS or something like that. So at the end of the day, the idea is to get your real world devices, which are then represented as context data within the context broker. So that's it for this particular session. We will be running more of these Wednesday webinars, and all that remains is me to thank you for your time and hope you have enjoyed the show.